All right. Whoop. This not being able to close my hand is, well, that's about it. Okay. So to continue our human history. All right. So humans did again. So humans did not evolve from apes. We have a common ancestor. Okay. By looking at fossils and genetic data, it is estimated that our common ancestor, where we kind of split apart, was 5 million years ago. That's a long time. So some hominoids went on to produce the old world monkeys, gibbons, and the apes, chimps. We talk about apes, we're about chimps, orangutans, gorillas. Our family, Hominidae, represents the ancestral and modern humans. We differ from apes. Okay, apes belong to the family Apongidae. When we look at the fossils, okay, we're going to see very different things. One of the things that we're going to notice is we get some anatomy here. This right here, this hole is called the foramen magnum. All right, so you have your spinal cord, and the tip of your spinal cord has this little spike called the atlas, and it kind of sits, the skull sits on top of it where that hole is. We're going to see how things have changed over time. One of our key features of being human is our ability to walk upright. Now, yes, orangutans and chimpanzees can do it. They can only do it for a short period of time. And, when humans have made them stand up, erect for movies and such, it actually is not good for them. Their bodies are not designed for that type of movement. They generally end up very arthritic, and have other health issues because of it. So here's just kind of a little family of Pongidae. So our orangutans, gorillas, chimps. So again, Hominidae upright posture. I talk about that foramen magnum. All right, so you can see the dogs is way back in the back. And then when we look at like our chimps, it's more back, and ours is more central. Okay, that is really important for that upright movement. And you can see here in the next picture. So when we look at the shark, so we're saying that foramen magnum is more here, right? Because the vertebrae goes back straight. Turtles, it's kind of the same thing. And this is just showing the primitive brain here. Rats, it's starting to move a little bit. You can see the angle here. Monkey, it's moved down here, but still the body's going to kind of go off here, where we're down straight. Okay. Again, this is really important for our anatomy to be able to stand up. And when we talk about, you talk about, well, why did humans have to stand up? All right, let's get to the anatomy and then we'll talk about that. And it's going to talk a lot about it in that movie. We also know that the femurs are angled to distribute weight downward in our family. If you look at what you're seeing here is a side by side of a chimp. This would be the chimp. This is us. All right. Notice that our hips are more directly out, where chimps is more out and then down. Our feet are also more developed for that particular walking movement. We have what's called the valgus angle. That valgus angle, it has to do with this angle here coming off the pelvic girdle. And we want it to be as straight. Let's get rid of all this. We want it to be as straight as possible. Notice here it's like kind of angled like that. And that causes the knees to be aligned for that upright movement. Matter of fact, females tend to have more this way because of our pelvic girdle being a little different than males. Our pelvic girdles are designed for having babies. And so this is why a lot of female athletes are having problem. It's called chondromalacia patella. Because of our valgus angle, our knees don't track quite as well as men's, and so the cartilage under the kneecap tends to get all chewed up in women athletes. It's a serious issue that hardcore women athletes, me, have. All right, and it's just, again, our bodies are designed to have babies. Okay. Also, notice the pelvic girdle opening here, since I'm talking about that, is much bigger in apes than it is in humans. It is really important because the baby has to go through that opening. And that's why when primates, when you start to move more erect, upright, these are modifications that have to be made. So for humans, we kind of sacrificed that ability to have babies that are more fully developed at birth in order to be able to stand up upright. And our ability to stand up upright, because remember, as the forests were shrinking, the grasslands became more plentiful. So if you could stand up and look around in the tall grass for predators, you were more successful. But with this particular adaptation, childbirth had to be earlier. We had to give birth to babies that were not fully developed. There are several genera in our family. We have the Australopithecus and Homo. So many of these species, we have many species of each of these genuses. So genus Australopithecus and genus Homo. So the oldest hominoids was the first fossils were about 4.4 million years ago. They had a chimpanzee-like skull with some human-like features, especially the teeth. Okay. So here's Lucy. Kind of already talked a little bit about Lucy. Okay. Lucy was a very exciting find. So again, we had about 40% of her. It's kind of like Sue. If you guys remember the T-Rex Sue, where they had most of her bones, and she was just, everybody was all excited about it. So Lucy has 1/3 of the brain size of modern men. When we talk about modern man, we're talking about us humans, men and women. Okay. It's just an old term. So she was about 1 meter. She was different than other Australopithecus. So one is one of the species of so Homo. Remember Homo species, or sorry, we have genus species. So genus Australopithecus, species Africanus. It was named because they were out of Africa. So our species name. We believe that particular species migrated out of Africa. We also have Australopithecus afaris, which they found in Afar, which is a region in Ethiopia. And again, the pelvis did indicate that she walked upright. So if we look at the bones, so here's her bones. There's her head. And it's really kind of interesting because if you think about forensic science has so paved the way for this. When we find, you know, dead bodies, skeletons, and we have been able to use different types of modeling to I don't want to say estimate, but to possibly show what that individual looked like. And then what's interesting is when they have found the parents or family members of the skeleton and they have pictures, those particular scientists can say, yes, we've got the modeling correct. And they have done a wonderful job. So now using old fossils, we have been able to, by using those techniques, kind of extrapolate what we think she'd look like with her skin and muscles. And so that is what we think Lucy looked like. Now notice, I'm going to talk about this a little bit here. Notice the flat, doesn't have much of a domed head, goes kind of straight back. Notice the big teeth. We're going to talk about these jaws and how significant those characteristics and how they changed over time. Then we have Homo habilis, which was named, again, more Latin here, handyman, because we found simple stone tools with these fossils. So the oldest member of the genus Homo is dated around 2.4 to 1.5 million years ago. Fossil evidence indicate that they did evolve from one of the Australopithecus species. They did have a larger brain, and they lived in as a in communal capes. And so here you can see we have our Australopithecus. This is cranial capacities in cc, cubic centimeters. And we can see how over time, okay, notice how we have this upright forehead. Many of our cognitive processes are in the frontal lobe of our brain. And notice how it has enlarged over time. And notice how the jaws have been reduced in size. Okay. So this is what we are hypothesizing to be the common, our one of our ancestors here, Homo habilis. Homo erectus, meaning upright man, because the skeleton was better adapted to walking upright. We have fossils that dated about 1.8 million years ago to 300,000 years ago. They were taller, they had a greater brain capacity than Homo habilis. We have fossils in Africa, China, Southeast Asia, and Australia. They probably evolved from Homo habilis. And there is a Homo erectus, early Homo erectus skull. So if we look at Australopithecus and Homo erectus, so we know that like Australopithecus was a walker, tree climber, versus Homo erectus was a walker and endurance runner. So we can see some of the anatomical differences and notice the change in the pelvic girdle. Notice the angle here. Also the arched feet versus the flat feet. All right. And the big gluteus maximus, which is your butt. Okay. That butt muscle, the glutes, are very important for running. Okay. In the video, they're going to show you it's just fascinating, that whole video, the significance of that particular trait. And then here we have just kind of a picture of, a modeling of walking of Homo erectus. So hominids walked upright for about 2 million years without a substantial increase in brain size. When you walk upright, it frees your hands. So for hunting, gathering, holding children, okay, instead of brachiating and the knuckle walking that chimps and stuff do. After 2 million years ago, brain size started to increase and tools started improving. So Africa started drying up around 2.8 and to 2.5 million years ago. We have climate change, and we have seen how the climate change has driven changes, driven speciation, adaptation. You either have the ability, the characteristics, or survive, or you die. We do believe Homo habilis and several other species of Australopithecus coexisted, but remember how I talked about competition. And as that competition increased, Homo habilis won. Okay. They won over the other types of organisms. And, and it's not this timeline, our answer is not a straight line. We have all kinds of dead end branches that just didn't make it. All right, so you can see we have the Australopithecus afarensis, Africanus, Homo habilis. There's some other ones here we didn't even talk about. And then we have Homo erectus. Notice we have Homo neanderthalans, and then us. Right, so that would be your cavemen, or Neander. A lot of people say Neanderthals. Well, really, it's Neanderthals. It is from those fossils were found in the Valley of Neanderthal, which is where that term comes from, right? Which is in Europe. Fossils found in Africa, Europe, and Asia. We have Java man and Beijing man that lived from 1.8 million years ago to 250,000 years ago. Homo erectus was taller than Homo habilis, had a larger brain capacity, allowed them to move to colder climates because they had the ability to problem solve. They could build huts and fire and make clothing, which enabled them to survive better in those habitats. Neanderthals, descendants of Homo erectus. Like I said, they were, we have the Valley of Neander in Germany, okay, which is what they were named after, and their fossils date them at 130,000 years ago to 35,000 years ago. And if you think about the timeline of our planet, 35,000 years ago is not that long. Some of the characteristics is that the Neanderthals had a heavier brow ridge. They had a less pronounced chin. They did have a larger brain size, and they were very skilled tool makers. And we did find that they had burial rituals. So they had basically, I don't want to say graves, but they had a location in which they buried their dead, and they tended to put um, objects with the dead, which indicated that they did have burial rituals. So basically, they're starting to think about the afterlife. If we compare a Neanderthal to a Homo sapiens sapiens, okay, that's us, you can see, I mean, look at there here, 1600 is the maximum here that we've found versus humans. Us humans, we're all humans here. Occipital bone has to do with one of the bones in your brain. We can see that they had this bun shape. It's kind of in the back here. Ours is more rounded and arched. When we talk about the cranial vault, remember I talked about that flattening, where ours became more domed shape. So it allowed the front part of our brain to get bigger and more developed. Mandible, they had a bigger, larger jaw. Right. And here's that frontal bone with that sloping forehead. And teeth. They had bigger teeth, and they had this gap behind their third molar. So there were differences. So when we look at the skeletal comparison, when we look at Neanderthals so here's our Neanderthals right here versus us. Okay. And then here's some kind of pictures, what we believe, what a Neanderthal looks like versus a modern man. I swear this looks like Vin Diesel. I don't know why. Maybe you see it. I see it. Not to imply that he's a Neanderthal. All right. So another question. Well, if we go back to this whole thing, because a lot of people are like, okay, Neanderthals and modern man, Homo sapiens, they did coexist. A lot of people are, well, what happened to the Neanderthals? Most likely we killed them off. All right. There's a couple different concepts or ideas that we either killed them off or we interbred with them. And with DNA techniques that we have today, we are finding that our species has some Neanderthal genes in it, which would support the interbreeding of these two species. So the next question then would be like, okay, how did we get ethnicity? How did we get these different, Asians and Caucasians and, African? How did we get these different ethnicities? So we talk about model one. Neanderthals gave rise to modern humans. And what we say is, all right, we had parallel evolution in different regions of the world. So as we diversified, there were differences or different characteristics that were more successful in those environments. Here's that interbreeding. Remember, we talked about gene flow. So we had that interbreeding between groups. So here is that parallel evolution. So we can see we have African Homo. So when they stayed in Africa, some were in Asia versus European and Indonesia. And so we can see how they branched out and then they independently adapted to those environments. And for whatever reason, those mutations, adaptations were successful in those different regions of the world. Model 2. All right, so they argue that the odds of evolving the same in multiple. So what we're saying is, okay, our ancestor moved out of Africa, settled in different places, and then went from like Homo habilis to Homo erectus to Homo sapiens independently in all those different regions of the world. Remember Occam's razor? That's, how would this independently evolve like in multiple places? Right? It's the odds are slim to that. So model 2 says that, no. All right, so we have what's called the out of Africa, which meaning that modern man evolved from a descendant of Homo erectus in Africa, and then out of Africa, our relatives moved out of Africa and then migrated and to different regions that they could, right? They didn't have ships and stuff. So we're talking, the land bridge between Africa up to Europe, and then, China and all that, Indonesia. Okay. Now, eventually, we'll get to North America. So basically, we're saying, okay, if we have the out of Africa model, what we're saying is that all our descendants are from a few individuals. We think that was about 100,000 years before present. And we can tell this from looking at mitochondrial DNA. Now, if you remember with the mitochondria, ooh, that's an awful mitochondria. Let's, because you're more, okay, had a circular strand of DNA which supported the endosymbiotic theory. Now we look at that because remember, there's not going to be any genetic recombination. Okay, they're going to reproduce like bacteria, so asexual reproduction. We do know that there are mutations, right? So remember our molecular clock. So we're going to use that idea, that concept, that tool to say that we believe that we can trace back to Eve in Africa. Okay. Now remember, all of you, your mitochondrial DNA is identical to your mom and your mom's mom and your mom's mom, and you can keep going back. Okay. So we can keep going back to Eve. Okay. Now, we can also use the Y chromosome because the Ys you never have two different Ys together. Okay. So a male's Y chromosome. So if you're a male, your Y chromosome is identical to your dad, your dad's dad, your dad's dad's dad. And we can keep going with the same concept that we did with the mitochondrial DNA for Adam. Okay. And this also supported the out of Africa model. So it is believed that Homo sapiens us have evolved from Homo erectus in Africa, and then we migrated out. Right. So when we look at this, from one population, we think this happened around 500,000 years ago. This includes the archaic old forms of Cro-Magnon and modern humans. And here is that particular, and you can see that particular migration pattern. Now notice here, that would be the Bering Sea. So during that period where the water level dropped, we had a land bridge here that would connect, humans could easily cross to basically Alaska and Canada, and then go down, migrate down to, North America and then South America. And here's just kind of a side-by-side comparison of Homo erectus, Homo sapiens, and Australopithecus, our ancestors. So Cro-Magnon, we tend to use that word for modern man. And again, did he outcompete Neanderthals or did they merge into one species? So when we look again at that mitochondrial DNA, it shows that the Neanderthal mitochondrial DNA is very different from modern Europeans. So fossil finds have implicated that the two migrations did not intermingle. That's what the fossils implied. But we have, with modern technology, have found Neanderthal genes in us, right? So it is known that like I said, two species cannot occupy the same niche at the same time. One will win. And so apparently Cro-Magnon were more successful. There has been so many ideas because Neanderthals don't have a very well-developed voice box. So it was thought at one point in time that we outcompeted them because we could communicate, versus they struggled with that because they couldn't really talk very well. New fossil finds are saying that may not be true. So again, we're still trying to figure it out. All right, so we entered Asia and Europe around 100,000 years ago. Ethnic groups are a result of microevolution. We talked about that. Pigment. More melanin protects from UV light. Less melanin allows better vitamin D absorption. So humans that live near the equator, and I'm not talking present time, but in the past, if you live closer to the equator, you know the sun is more intense. You will burn. If you have fair skin, you burn. You will then most likely end up with skin cancer and die. Those with darker skin, with more melanin, are protected from UV light. So individuals with darker skin were more successful. Now you need UV light in order to make vitamin D. Without vitamin D, you can take in as much calcium as you want. Your body has a hard time absorbing it for bone formation. Now, if you're towards the equator, the sun is quite intense, and even with having dark skin, which protects you from the UV light, you're still going to get enough UV light through to make vitamin D. Okay. So it protects you from skin cancer, and you're still able to have strong bones. As humans migrated north, as you know, especially being in northern Illinois, the sun is not very intense. And so if you had dark skin, you couldn't make enough vitamin D. And so your bones would be brittle. And of course, back then you broke a bone could kill you. All right. So individuals that had lighter skin were more successful. Right. So you'll notice, and it doesn't matter whether you're going north or south, like if you go down to like southern Chile and Argentina, their skin is fair. All right. Now, today, of course, we use sunscreen and stay out of the sun, but we didn't have that option 100,000 years ago. All right. So depending where those ancestors migrated and ended up, whether you had dark or light skin, would be that particular adaptation that either made you successful or not. We also have what's called the Bergman's rule, and that has to do with body shape, right? If you are tall and thin, you can dissipate heat really well. If you are short and, well, we'll just use the modern term, fluffy. If you are short and fluffy, you do not get rid of heat really well, okay? And if you're short and fluffy, you realize that you don't do well with heat, okay? If you are skinny, you do much better with heat. Now, in the winter time, those people that have more fluff, right, more insulation, they do very well in the cold temperatures. And the skinny, tall people are going to freeze. They're going to be very cold. So when we look at body proportions, especially around the equator, they had dark skin, they were thin. Versus as you get to the northern latitudes, you tend to get people that were more, shorter and their metabolisms were slower, so they could have more insulation, be more fluffy, and they did better in those particular environments. So like I said, in colder climates, the shorter limbs and bulkier bodies do much better. We also have what's called the Allen's rule. And so shorter digits, shorter fingers, and littler ears, they also help prevent loss of heat. Okay. So again, we can expect the opposite to be true in warmer climates. So these characteristics cannot be explained for physiologically um, for like we can't figure out, well, how did these particular adaptations, these characteristics help humans in their environment? For example, upper eyelid fold, and that would be like in people from China and stuff like that, the squinty eyes. Like we know, like the Eskimos, we believe that helps with the glare off of the snow and ice. But for Chinese people, we have no idea. We also have lip shapes. As you guys know, many Africans have really thick lips, broad noses. We can't explain why. We can't figure out why that was more beneficial for them. Hair texture, we kind of have an idea because early on, how Africans have the real kinky curly hair. They also secrete a lot of oil, and we have found that lice, they do not like that hair texture. So that could be an advantage for individuals living in that part of the world where lice could be a problem. But again, we're not 100% sure. And lastly, we have our we're going to end with another family tree. And you can see where some branches w- they didn't last long. They were clipped pretty early. And then we can see here, there we are. And then again, we were very close and cohabitated our planet at the same time with Neanderthals. And that is it. So again, please watch the Becoming Human. I know it's a few hours, but it is going to talk about so many and show you so many different things about how we evolved. One of the more important things we're going to talk about is fire. With fire, we were able to cook our food, which made it easier to chew, which allowed our jaws to reduce in size. And you need this huge muscle here in order to operate those strong jaws. And so with the reduction of not needing that strong jaw, it allowed for our brains to become bigger. A high protein diet also allowed our brains to be bigger. And they're going to talk about all of this in the video. All right. Well, I hope you enjoyed this class. I enjoyed teaching it. I hope you guys learned a lot about evolution. And as always, you have questions, let me know. And be sure, please, if you can do the course evaluation, I would greatly appreciate some constructive criticism. Maybe what you liked, what you didn't like, and maybe how I could make that better, because I'm always working on improving my teaching. All right. Thank you and good luck and best wishes moving on from this class. All right. Bye.